Okay, here we go. We are working on Chapter 1, Section 5, Combinations of Functions. And so let's go over real quickly. When we see something like f of x, we know that means, yes, it does mean y. It's the same thing as y, but it's a cool way of representing y because it says what's the function's value at x. F of x means the function's value when we're at x. And so we know what that means, but then when we see f plus g of x, it's kind of interesting. What does that mean? When we see it, it means f of x plus g of x. It may look like we are distributing the x, not technically, but I want you to know that what this notation means. Same thing if we have f minus g of x. Yes, you're right. It's f of x minus g of x. And then I think we'll be able to guess what f times g of x is. It is f of x times g of x. And of course, f divided by g of x is the same thing as f of x divided by g of x, as long as g of x isn't 0, of course. That should be a review. Let's go ahead and see how we're going to use this. We're given two functions. The first function is f of x, so it says let f of x equals 7x minus 5, and g of x equals 3 minus 2x. Find f minus g of 4. So the first thing I'm going to do is I'm going to rewrite, when I see f minus g of 4, I'm going to remind myself this really means f of 4 minus g of 4. And once I see that, then I can go ahead and say, well, here's my f of x. I go ahead and find the value of the function when x is equal to 4. That means I'm plugging in a 4, right? So I'll have 28 minus 5 is 23. So that's my f of 4. And then let's go ahead and do my g of 4. So g of 4, I'm just going to plug in my 4 when I see the x. So I got what? 3 minus 8, which is negative 5. So if I want f of 4, which is 23, minus g of 4, which is a negative 5, then I know that I get 23 plus 5, which is a 28. Example 2, what if we had f of x equals 2x plus 1 and g of x is equal to x squared plus 2x minus 1, and they wanted us to find f plus g of x. The first thing I'm going to do is remind myself that that means f of x plus g of x. So that means I'm just adding the two functions together. So I'm going to have 2x plus 1 plus x squared plus 2x minus 1. And I'm just going to go ahead and gather the like terms. There's nothing to combine x squared with, but I have 2x plus 2x, which is 4x. And then the positive 1 and the negative 1s cancel each other out. So this is my answer for part A. Then it says evaluate the sum. So the sum we have is x squared plus 4x when x is equal to 2. So now we're going to go ahead and just plug in 2 when we see x. So we're going to have 2 squared plus 4 times 2, which is going to give me what? 4 plus 8 is 12. So that's the answer to part B. Part C is f minus g of x. Once again, I'm going to remind myself that that's the same thing as f of x minus g of x. So it's just saying take the function f of x and subtract the function g of x. So I'm going to put parentheses here. I'm going to put parentheses, and all I will really be subtracting is just the x squared. I want to be subtracting the whole function. That's why I need those parentheses. So I'm going to distribute that minus sign first before I start to gather like terms. So I'm going to distribute it to the x squared and to the 2x and to the negative 1. And then I'm going to go ahead and start gathering like terms. I've got the negative x squared, and then the 2x's go away, and then 1 plus 1 is 2. And then part D asks me to evaluate the difference when x is equal to 5. So I'm just going to go ahead and plug in 5 for x. I'm going to sneeze. Excuse me. All right. So I've got negative 25 plus 2, which gives me a negative 23. So this is very basic stuff. It's just a reminder of notation and what we do when we have functions. So here it's asking me to find f divided by g of negative t. I'm going to right away rewrite that. That is f of negative t over g of negative t. I hate when they use t. It looks too much like a plus, and that's why you see me squiggle that bottom part of the t so it doesn't look like a plus. So I'm going to look at f of x. That function is equal to x squared plus 2. And I'm going to remind myself that f of negative t just means putting negative t wherever I see that x squared. Okay? Same thing with g of x. If I want g of negative t, that means every time I see an x, I'm going to plug in a negative t. Don't really need those parentheses, do I? All right, so I'll have a negative t minus 3. And then I'm going to simplify the top, and I'll have what? T squared plus 2 all over negative t minus 3. Nothing cancels out. That's right. Nothing cancels out. Whatever addition or subtraction bring together, let nobody tear apart. All right. What's the domain? So we're looking at this right here to find the domain. And the domain, most of the time when we're dealing with basic polynomial functions, the domain's anything, all real numbers. But in this case, because we have our denominator, we know that our denominator cannot equal 0. So what we want to do is set it equal to 0 so we can see what t cannot be. So I'm going to add 3 to both sides, and then I'm going to divide both sides by -1 or multiply both sides by a negative. However you get rid of that negative, we see that t is equal to -3. So we know that t cannot equal -3. And then it asks me about my domain. I can't put, in the old days, I used to be able to put all reals, x not equal to -3. But now we've moved up, we're in pre-calc, and they want us to put it into interval notation. So let's do that. Basically it's saying all reals are all the numbers that we can find on a number line. Did you know that? Every single number on the number line is a real number. And so all of these will work except for -3. So we're going to have a big open circle at -3. All the numbers to the left of -3 will work, and all the numbers to the right. So we're going to write that in interval notation. So there's going to be two intervals, right? All the way from -infinity to -3. We use parentheses for -infinity because we can never include a concept. -infinity stands for numbers that exist as far to the left as you can imagine on the number line. And then, of course, we're putting parentheses for -3 because we are not including it. And so it's that and that's an upside down U. It's also from -3 to infinity, both with parentheses. So this right here, this interval notation means the same thing as this right here. Okay, composition of functions. This is fun. This is where we've got the funky open circle right here. What does this mean? It's fog, right? Fog and Goff. So let's see what fog and Goff means. So when we have that, that's really saying f of g of x, which is kind of fun. Actually, I like these problems. And then Goff is g of f of x. And so it's the way I remember it is that the first letter that we see is going to be first when we rewrite it, right? And the second letter that we see is always going to be the inner part of the function. It's going to be included in the inner part. And that's what this says with these words. Let's see if there's anything else on this slide. So let's have fun with this. We're going to be given that we have two functions. We have the first function, f of x, is 5x plus 2, and the second function, g of x, is x squared minus 1. So for some reason, I have these all typed out, so we'll just go through it without me writing. When we have fog, what we're going to do is remember that we can rewrite it as f of g of x. But don't mind that squiggly blue line underneath the g. It doesn't mean anything. So basically, this is what we're doing. We're taking first the g of x and we're plugging it in. So we see that g of x is x squared minus 2. That's where, see how it says g of x is in there? That's right. That's why we're putting it right in there. So now it's telling us that we're having this function f. So over here is our function f, right? It's our f of x. And we're plugging in x squared minus 1 wherever we see x. So that's our next step. we're going to go ahead and see how we had 5x plus 2. Instead of writing an x, we wrote x squared plus 1. I'm sorry, x squared minus 1. And once we did that, we're going to go ahead and just simplify it. The hard part is over. We're just going to simplify. We're distributing the 5. We're combining, we're combining like terms. Let's get rid of this. Ooh, bounced back up. That was interesting. So once again, we distributed, we combine like terms, and that's it. Do you think fog is going to be the same thing as goff? Yeah, I don't think so either. Sometimes it could be, but not this time. So here we go. We're going to remind ourselves that goff is g of f of x. Once again, don't mind that squiggly line underneath the f. And then what that means is that, let me get rid of these so that we can just start anew on this side. What that means is my f of x is 5x plus 2. So that means I'm going to plug in 5x plus 2 where it says f of x. So that's my next step. Boop, plugged it in. Then it's got g, so I'm going to remind myself what the function of g is. G of x is x squared minus 1. So this time, see how we've got 5x plus 2? So instead of writing x squared minus 1, we're going to plug in 5x plus 2 in the x spot. So here we go. We're plugging in, whoops, got to put that down. We're plugging in the 5x plus 2 in the x spot. And then we're going to expand 5x plus 2. So when we do 5x plus 2 times the quantity 5x plus 2, we get 25x squared plus 20x plus 4. And then we rewrite the minus 1 here. And the very last thing we're going to do is combine the like terms. 4 minus 1 is 3. So we see that fog is definitely different than goff. Let's see if we've got anything else in this section. Okay, we're going to practice again. This time, for whatever reason, I have something already written down. So here we've got two different functions. F of x is equal to the square root of x, and g of x is equal to 4x squared. So fog, once again, that's going to be f of g of x. So we're going to remind ourselves that. So that means that we are taking this function, we are taking square root of x, okay? But what we're going to do is instead of plugging in x, we're going to plug in g of x. So what is g of x? G of x is 4x squared. So that's what we're going to be plugging in right there. So that's our next line, right? F of 4 of x squared, which means we're going to take the function f, which is square root of x, and instead of an x, we're going to put in 4x squared. And that's what we do. And then we're just going to simplify. So the square root of 4 is 2, the square root of x squared is x. And okay, so we've got the absolute value of x, which means that x needs to be a positive number. We'll talk more about that in class. Let me look back up here. Oh, x, absolutely, we know x. We don't have to talk about it in class, we're going to talk about it now. Look at the function for f. It's a square root of some number x. And we want to make sure that when we're simplifying, we remind ourselves, oh, that's right, x has to be positive. Otherwise, the function is not going to be a function, right? It'll have imaginary solutions, and we don't want that. We want it to be keep x positive, and that's why we put the absolute value there. And so then when we're looking at goff, we know that, let me erase this stuff up here, my g of x is 4x squared, and we're going to take 4x squared. Well, first let's remind ourselves that goff is really g of f of x, and then we're going to take f of x, which is square root of x, and we're going to plug it in. Okay, I'm not sure what happened there. All right, let's see. So we're going to take our f of x, which is square root of x, and we're going to plug it in. So we have g of square root of x. And we're going to remind ourselves that g, the function g, is 4x squared. So that means that we're going to plug in, when we see x squared, we're going to plug in when we see x squared, we're going to plug in a square root of x. And that's what we did. We saw 4, we wrote a 4. We saw an x squared. Nope, we're not writing x anymore. We're writing square root of x. So we know square root of x squared is just a 4x. All right. And then we're reminding ourselves, that's right, x has to be a positive number. So x has to be greater than or equal to 0, once again, because we have the function square root of x. Okay, I think that's what we've got. Let's see, that's it. Thanks for joining me, and I look forward to seeing you in class.